In this video we have two definite integrals to evaluate, and they're both going to involve a U-substitution. For the first one, I'm going to let u equal to minus x squared over 2. That's the exponent on this exponential. And I know it's going to work because the derivative of minus x squared over 2 is minus 2x over 2, which will give me a minus x. And I've got an x over here. So du, derivative of minus x squared over 2, okay, the 2 comes out in front, it cancels, and I get minus x. And then dx. And it's multiplied through by a negative, I get minus du is equal to x dx. So I'll put an equals here, and then we'll cut down over here then. Let's convert this. The x dx will be minus du. I'll put the minus out in front. I've got the du here. And then I have e. And the exponent, of course, is u, so this is e to the u. Now we could go ahead and do the integration here and then go back to the original limits of integration. But let's just do this. When x is equal to 0, the bottom limit here, x equal to 0. This will be 0 squared minus, but this is going to be 0, so u would be 0. That'll be the lower limit. Upper limit is 2, so when x is equal to 2 here, doesn't square the negative, okay? So it's 2 squared is 4, divided by 2 is 2, and then I got a minus, so u would be negative 2. So then the new limits then would be 0. Instead of 0 to 2, it'll be 0 to negative 2. And then we integrate. Integral e to the u with respect to u is e to the u. And I still have the minus here. And then we integrate from 0 to negative 2. Okay, evaluate a negative 2 here. It'll be minus then, minus e to the negative 2. And then we subtract the value at the lower limit. So we evaluate this at 0 here. Again, it's e to the 0, there's a 1, and then a negative. So that's a negative 1. So this is minus minus, so I'll put the 1 in front. So it'll be 1 minus e to the negative 2. No constant of integration because this is a definite integral. And you can evaluate this. I'm going to give exact answers in this one. If they ask you for an answer in decimal form or approximation, you could use your calculator to compute this. But I'm just going to leave it 1 minus e to the negative 2. So we'll call this the answer. Now for the second one, I'm going to use a formula that I used in an earlier video, and I've used it in other videos. It's this one right here. If you have the integral of ln of u over u with respect to u, and this could be an x here. This could be ln of x over x dx. And this would give you then, if you have the x here, this would be ln of x squared over 2 plus the constant of integration. If it's the u here, then it's ln of u squared over 2. Same thing. In our case, it's going to be u because what we're going to do is use a U-substitution. So let's go back to this one then. And I'm going to let u equal to 2x plus 3. That's this part right here. And then du equal to the derivative of this, which is 2. Then I've got the dx. Divide through by 2 here. This cancels out. So we're going to transform this integral into one involving the variable u. So I might have a u right here and a u in the bottom here. And then I'm going to change the limits of integration here. So for here, x is equal to 1/2. Lower limit, upper limit, x equal to 1. So at 1/2, when x is equal to 1/2, put a 1/2 here. I get 1/2 times 2 is 1, 1 and 3 is 4. So the lower limit would be 4 instead of 1/2. The upper limit, x equal to 1, I get 2 times 1 is 2 and 3 is 5. Upper limit then would be 5. So then this would equal to, lower limit then is 4. Upper limit is 5. Transforming it into one involving the variable u, so this would be ln of 2x plus 3, that's your u. In the denominator, 2x plus 3 again, that's your u. The dx is replaced by du over 2, so I'll put du here. The 1/2, I'll put it out in front. It's constant, so you can always bring out a constant from inside the integral. Now we have it set up the way I want it. So this is going to be using the formula that I just went over with you. Integral of ln of u over u is ln of u quantity squared over 2. We have a definite integral. This is evaluated then from 4 to 5. So remember, we evaluate at the upper limit, put a 5 there, and that's going to be squared. And then we subtract the value at the lower limit. So I put a 5 there, and notice I have a 1/2 here and a 2 there, so multiplying this out, this will give me a 4. So this actually will come out to ln of 5, and this is squared, and then 2 times 1/2 here, or 2 times 2 there, the denominator, that's going to give me a 4, and then it's minus the value at 4. So if I put a 4 there, same sort of thing, quantity squared, and again you still have the 1/2 multiplied by the 1/2 here, I have the 2 in the denominator, so this will be a 4 here. So we have ln of 5 quantity squared over 4 minus ln of 4 quantity squared over 4. So this is your answer again, and that's the exact answer. If it asks for a decimal approximation or something, then you can use your calculator to compute that out. Thanks for watching. We'll see you next time.